In this video, I'm going to be finishing off the compiler that I started in part 1, which is linked in the description. In part 1, we made a parser which reads a file that looks like this and outputs a syntax tree that looks like this. In this part, our goal is to make a C file that the user can actually run. The C file is going to look like this. And in order to run it, you just have to call the C compiler on the file and run a.out. So let's start writing the code generator that generates the C file. So toward the top of the file, we have the parser that we wrote during part 1. So the code generator, first what we should do is we should just go line by line, statement by statement, and convert each statement into a statement in C. So statement to C. And the C file is going to be a string. So I guess let's start with the assign statement. Statement to C, assign variable to a number. Now, how do you write assignment statements in C? Instead of doing assign vn, you would do something like v equals n. The one difference being that v and n are variables, so we need to do v plus plus, and we need to do n here. And we need to convert n to a string using show. We can do the same for addition statements. So add a b in C form would be a plus equals b. Except a and b are variables, so we just need to do a and b escaped from the string. Now let's do a print statement. So print variable v. In C, the way we would do this is printf %d new line followed by our variable name. Except we need to escape these string characters, these quotes. We also need to escape this backslash here. And this v is a variable, so we need to add it on. And finally, we have the while loop. So while v is positive, run the following code. So the way we would write this in C is while v greater than 0, new line, then the code would just go in here, and then closing bracket. So escaping the variable should be pretty easy. You just type ++v. But C is not a statement. It is code, which is just a list of statements. So we need to make a new function that converts a list of statements into a string. So statements to C. Where's my cursor? There it is. So the first thing we do when we have a list of statements is we need to map statement to C over the list. So we convert each statement individually into a string. And then once we have a list of strings, actually let me just show you what that would look like. Oh, let's just comment this out for now. So let's say we have the following statements. Print a, add a b, assign a 5. Now, if we do map statement to C over this list, it converts each of them individually into a string. So we have the list. Now we want to join these strings together with new lines in between them. And luckily for us, there's a function in Haskell that can do this called unlines. Let me print this as a string. So unlines inserts new lines between every statement and also adds a new line after the last one. So we could do the same thing here. Unlines, map statement to C over this code. Let me just rename it to statements. And now we can write this while loop. So instead of this code being just variable C here, we need to first do statements to C on this code. So now let's test this out. Statement to C on a while loop, while A is positive, print A, and I don't know, assign A equal to 0. And now we have while A greater than 0, printf A equals 0, which is exactly what we want. So now let's actually run this on our input and write it to an output file. So we can do this by changing the main IO function. So we have parsed here. Let me just remind you what this parsed variable is going to look like. It's going to be write followed by a list of statements that were parsed from our code. So in order to first get the write out of it, we need to do case parsed of. So this is an either, which means it can either be left or right, as I explained in the previous video. So if it's left, and then it's going to have an error message associated with it. Let me show you what that would look like actually. Now we get a left followed by an error message. So if we have that case, then we can just print the error message. But if we have right followed by the parsed code like we have in this case, then we can run statements to C over that to get a string. And then we can write it to an output file. So we can do write file output.c, statements to C, and then the code. Now if you run it, oh, I still need to fix the file. Now if we run it and we look in output.c, we'll see that these match up with what they should be given input.text, because we have a equals 5 turn into a equals 5 semicolon, b equals 1, b equals 1. While a is positive turns into while a greater than 0, print a, printf, a plus equals b, a plus equals b. So that's good, except obviously we're not going to be able to compile this right now because first of all, these variables are not defined. And second of all, this needs to be written inside, these variables are not defined. And second of all, it needs to be inside of some kind of main function. Let me remind you again what the reference compiler output looks like. We have all the variables defined, and we need to have int main go around the whole thing. So the easiest thing to do here is to put the int main around it. So let's write a function that puts int main around our code and then calls statements to C on the list of statements. So let's call this code to C. Code to C, code equals, first we need to include standard IO so that we can have printf. So include standard IO.h, followed by a new line, followed by int main, followed by another new line, Then for now, we can just call statements to C on our statements. And then finally, we have return 0 and a closing bracket. Closing bracket. And then we can replace statements to C down here with our new function. Now if we call our compiler, we see that we have include standard io.h, int main, return 0, closing bracket, and then the same thing we had before. So if we call GCC on this, now our only error is that we have some undefined variables. So in order to fix this, we need to make some declarations towards the top. That would look like this. We need to have int a and int b so that GCC knows that these variables are going to be integers. So the first thing we need to do in order to declare int a and int b is we need to know what the list of variables that we have in our code is. So let's write a function that does this. Let's call it code variables. Actually, the first thing we should do is we should have finding what variables are in a statement. So statement variables goes from statement to a list of variables. Did I misspell this? I did misspell this. Yeah, okay. So statement variables. First of all, the easiest thing to do is for a print statement. The variables in this statement are just the variable that you're printing. In an assign statement, assign v to a number. The variables in this are also just the variable that you're assigning. When you have add ab, then we have two variables, a and b. And finally, in a while loop, we have the variable, and then we have all the variables that are assigned to or read from in this loop down here. So just like we did before where we have statements to see, now we're going to do statements variables. That gets all the variables in a list of statements. So statements variables, statements equals, we're going to do the same thing here where we map statement variables over all our statements. And then the way we would join these together is, let me first show you what that list would look like. So let's make some statements. Add a, b, print a. So if we map statement variables over this, it would be, oh, I misspelled it. We would have a bunch of lists in a larger list. And the way we convert this back down to a single list is we want to flatten it. And the way we can do this is using the concat function. So we call concat on this big list, and it flattens it into one single list. So let's show what that would actually look like with this map statement. So concat. And now we have exactly what we wanted. So let's put that in our code. All we need to do is call concat over here. I think I misspelled something. Oh, I misspelled statement again. Line 44. Statements. Oh, yeah, there we go. Come on. Oh, okay, I also need to get all the variables in the case of a while loop, you need to get all the variables in C and then add them to just the single variable V. So single V plus statements variables on this code over here. I keep misspelling statements. There we go. Okay. So let's try this out. We're going to call statements variables, actually just statement variables, on a while loop, while a is positive, print v, and I don't know, add c or a and c. And we get all the variables that are present here. So this is good. We have a list of variables. Now we can start writing the declarations for the variables, which are going to look like this: int a, int b. So write a function where we make declaration variable to a string. Make declaration v equals int v semicolon. So this was pretty easy. Now we need to make another function that makes a list of declarations for a list of variables. So make declarations list of variables to, we want a single string at the end. So we're going to do exactly the same thing we did in statements to C, where we map make declaration over the variables, and then we unlines it to put it together into one big string. So make declarations variables equals unlines map make declaration over v. And now let's see if that compiles. Oh, yes. Good. So now we can put this function into our actual final code generator. So we have this part here that adds all the statements. So before that, we need to add in our new function that adds all the declarations. So make declarations on statements variables code. And let's see if it works. Good. So we have include standard IO in main. Now we have a bunch of declarations, and then we have all of our lines of code followed by return 0 and a closing bracket. I'm not sure if if GCC will be able to compile this. Actually, let's find out. Nope. Okay, it's redeclaring. So we need to make it so that there's no duplicates here, because variables keep getting declared over and over again. And the reason for that is the list that gets returned by statements variables is allowed to have duplicates. So the way we can solve this is by having, instead of a list of variables, a set of variables, because a set is a data structure that is not allowed to have any duplicates in it. So what we're going to do is we're going to import data.set, which has utilities for working with sets in Haskell. Specifically from data.set, we're going to import the set data type, and then I'll add some more later on to that import. So statement variables is going to go from statement to set var, and statements variables is going to go from list of statements to a set of variables. So how do we convert this list of variables into a set of variables? The way we do that is using the function from list. So let me show you this on the REPL. So from list A, B, C returns a set from list A, B, C. But if we try to put duplicates in here, it'll just remove the duplicates. Oh, you know what I can actually do? Instead of having these return a set of variables, I can just do toList from list. So from list turns it into a set, removing all the duplicates, and then toList turns a set back into a list. So this is actually much easier than what I was planning on doing. Yeah, okay. So we're going to leave these functions unchanged, and then we can make a new function, code variables, which goes from list of statements to a list of variables. And what we can do here is we can do kind of the hack I was talking about with toList and from list, where you can do code variables, code equals toList from list, and then statements variables from the code. This is good. Okay. Now I don't need to import the set data type. I do need to import toList. Now let's see if this compiles. Oh. Compiler.hs. Good, that compiles. Okay, so now changing one more thing, which is that instead of calling statements variables in code to C, we can instead call code variables. And let's see if it works. Compiler our compiler, and then run our compiler. Good, this is exactly what we wanted. Now we have int a, int b, no duplicates, and we should be able to call the C compiler on this, and it should compile it correctly. Very good, and then we can run a.out. It does exactly what it's supposed to. So we pretty much finished our compiler now. I'll post the code for the compiler in the description of this video. Now, one more thing before we go. Let's write something a little bit more advanced in this new language that we just made. So what we're going to write is we're going to write a Fibonacci number calculator. So for people who don't know, Fibonacci numbers are 0, 1, and then every number afterwards is the sum of the previous two numbers. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, and so on. So if we want to calculate the Fibonacci numbers, we can use the following pretty simple algorithm. We have a equals 0, b equals 1, and then repeatedly make a new variable, a temporary variable c, which is a plus b, and then assign a equals b, and then b equals c. So we're kind of shifting one to the right. And then if we want to print out all the Fibonacci numbers one by one, we can just print out c, or print out b. Now we need to make a few adjustments to this in order to convert it into a language that the compiler can read. First of all, we can't just do it repeatedly forever. We want to have some kind of boundary. So we're going to make n where we want like the nth Fibonacci number. So let's say we want the first 10 Fibonacci numbers. So while n positive, and then at the end we should do n minus equals 1. The next thing we should notice is that we're not allowed to have minus equals. We can only have plus equals, so we do plus equals minus 1. The next thing you'll notice is that you're not allowed to plus equals by an integer. You have to do it by a variable. So we're going to make a new -1 variable, and then plus equals by that. Another thing is that you're not allowed to assign a variable to a variable. You have to assign a variable to a constant number or add a variable by a variable. So the way we can get around this is a equals 0, a plus equals b for this case. And in this case, b equals 0, b plus equals c. And here we have c equals a plus b. The way we can get around this is c equals 0, c plus equals a, c plus equals b. Now I'm pretty sure this should print the first 10 Fibonacci numbers. So let's run the compiler and find out if it works. GCC output.c, and then run a.out. 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, which I'm pretty sure are the first 10 Fibonacci numbers. So we should be good. So in these past 2 videos, we've written a compiler from start to finish for a Turing-complete language, and we've written code in this language that computes the first 10 Fibonacci numbers. I might make another video where instead of outputting to C, I output to assembly because that is like quote unquote more legit. So stay tuned for that, and thanks for watching.